Hi class, this is Sir Alex Basco and welcome to our lesson 3 part 2. So in part 1 we discussed all about Coulomb's law, how we got Coulomb's law. Charles Augustine de Coulomb managed to formulate the equation that we are going to use today to solve the magnitude of force that two objects with charges or two particles with charges either attract or repel. So that's all about the lesson today. It's just a bunch of sample problems in order for you to understand how and where to use Coulomb's law in situations. Okay, so let's begin with our sample problem one. It's a very simple one. Okay, so for sample problem 3.1, what we want to do is to calculate the attraction between the lone electron and proton in an hydrogen atom. So the average distance between them is 5.0 times 10 raised to negative 11 meters. Okay, so it is important to note that hydrogen is actually one of the weird things in the table of elements because it's the only element without a neutron. It's a hydrogen is only composed of one electron and one proton. Okay, so what we want to do is calculate the attraction force. We know that it should be attraction force because electron is negative while proton is positive, and we know that unlike signs attract. Okay, so the distance between these two subatomic particles is 5.0 times 10 raised to negative 11 meters. Okay, so how are we going to solve this? So we're going to do this first. Let's write our given. So the first thing that is given to us is one is we have an electron. Okay, so one thing that I want you guys to remember now is the value of the charge of electron. It's something that I want you guys to remember. The charge of an electron is negative. It's negative 1.602 times 10 raised to negative 19 coulombs. Okay, that is the value of the electron. It's a negative charge. So again, this should be a knowledge that I want you guys to remember. So just remember this. Even though it is not given in the problem, it is something that you should be able to regurgitate, to remember, to use immediately. So if I ask what's the charge of an electron, it's negative 1.602 times 10 raised to negative 19 coulombs. And we're going to do is we're going to call this our Q1. Next, in this sample problems, it is also stated that a hydrogen has a proton. So what is the value of the charge or the magnitude of the charge or the quantity of the charge of a proton? It is the same as electron, only it is positive. So proton has a quantity of charge of positive 1.602 times 10 raised to negative 19 coulombs. And what we're going to do, we're going to call that as our Q2. Okay, and the last thing that is given to us is we were given the distance. We know that the distance between this Q1 and Q2 is 5.0 times 10 raised to negative 11 meters. Something that I want you guys to remember, the distance that we have to always use is in meters since we're using newtons as our unit for force. Okay, next let's identify what is being asked. In this situation, what is being asked of us is the force of attraction. So we are solving for half, for not half, sorry. We're solving for F. And the formula that we have to use is basically the Coulomb's law because we discussed previously Coulomb's law is what we use to measure the magnitude. It's the formula that we have to use to measure the magnitude between 2-point charges. And we can think of these as our 2-point charges. And the formula for that is the force is equals to the constant K multiplied by the absolute value of Q1 multiplied by the Q2 divided by the square. So remember that force is directly proportional to the product of our charges divided by d squared. So d squared is inversely proportional. It's the inverse square force. Then let's head to the solution. It's quite an easy one. So what you will just want to do is plug in the numbers. So force is equals to, remember the value of K. The value of K is 9.0, or basically 9 times 10 raised to 9 Newton meter squared per Coulomb squared, multiplied by the absolute value of Q1. Our Q1 is negative, so we do not need to have the negative sign. So just remove the sign. Just okay. So we just remove the sign. So it's 1.602 times 10 raised to negative 19 coulombs, multiplied by the value of p again. So just remove the sign. So that's 1.602 times 10 raised to negative 19 coulombs. All of those divided by our d. In this case, our d, what you want to do with our d is to square it. So that's 5.0 times 10 raised to negative 11 meter squared. So just plugging in that on your calculator, you would get that the force of attraction between the hydrogen's electron and proton is equals to 9.2 times 10 raised to negative 8, and the units for the force is newtons. So it's quite easy, right? So that is how you use Coulomb's law to measure the force of attraction or repulsion between 2-point charges. In this situation, what we have is we have an electron and we have a proton, and they're being attracted towards each other. Okay, so the magnitude of the force of attraction is 9.2 times 10 raised to negative 8 newtons. So that's quite easy. Let's move on to our next sample problem. Sample problem 2. Okay, so let's read this. You have two protons and they're separated by a distance of 3.8 times 10 raised to negative 10 meters in air. First, what we want to do is find the magnitude of the electric force one proton exerts on the other. Is this force attractive or repulsive? And next, find the magnitude of the gravitational force one proton exerts on the other. Is this force attractive or repulsive? Okay, so in order for us to solve this, let's write our given. So first, our given is we have two protons. What that means is our protons, and then we have two Q's, Q1 and Q2, but they're both protons. And we know that the value of protons we just discussed is positive 1.602 times 10 raised to negative 19 coulombs. And we can call this as our Q1, and we can also call this as our Q2. So they have the same value. And the distance between them is 3.8 times 10 raised to negative 10 meters. Okay, so what is being asked? So there's two things that is being asked of us. A, we want to find the magnitude of the electric force. What we're going to do is I'm just going to write E here, so to denote electric force. And next, what they're asking us is it and is it attractive or repulsive? Next, they're asking us for B is the magnitude of the gravitational force. So gravitational force, and is the gravitational force attractive or repulsive? Next, let's write the formula that we have to use in order for us to answer each of these questions. Okay, so for Fe, the electric force we want to use is Coulomb's law because we are dealing with charges. So we know that K is equals to, or Fe is equals to K multiplied by the values of the products of Q1 and Q2, which are both protons, divided by the squared. Next, we know that for Fg, the gravitational force is equals to G multiplied by mass 1, mass 2 divided by the squared. Okay, so let's head to the solution. So let's solve for letter A first. Letter A is quite easy. In order for us to solve the value, or in order for us to solve the magnitude of the electric force, we just need to plug in our numbers. Fe is equals to K. We know that the value of K is 9.0 times 10 raised to 9 Newton meter squared per Coulomb squared multiplied by the absolute value of our charges, which is, or the absolute value of the product of our charges. Our Q1 and Q2 has the same value. So that's basically 1.602 times 10 raised to negative 19 coulombs multiplied by another 1.602 times 10 raised to negative 19 coulombs. All of this divided by the distance between these two protons, which is 3.8 times 10 raised to negative 10 meters, and we have to square that. So that is, let me just edit that, sorry, it's negative 10 meters. There you go. Okay, so just plug in that on your calculator and you would get that the magnitude of your Fe is actually equal to 1.6 times 10 raised to negative 9 newtons. And is this attractive or repulsive? We know that these are two protons. Two protons are both positive. Two same signs are repulsed. So this is a repulsive force. Okay, next let's solve for B. Okay, next let's solve for B. For V, we know that Fg, G, something that we have to identify first. One is M1, M2 divided by the squared. Okay, so some things that I want you guys to remember here are the value of G. G is a constant. If K is a constant and has a value of 9.0 times 10 raised to 9 Newton meters squared divided by per Coulomb squared, our G is actually 6.674. Just want you guys to remember this. This is always the value of G. This is constant. Times 10 raised to negative 11. This is also Newton meter squared per kilogram squared. So instead of Coulomb squared, we are using kilogram squared because we are measuring mass. So right now, we are looking at mass. Okay. What we have to remember now is the mass of protons. This is another thing that I want you guys to remember. If the last time I want you guys to remember the value of the charges of proton and electron, now what I want you guys to remember is the mass of proton. The mass of protons is actually equivalent to 1.673 times 10 raised to negative 27 kilograms. Okay, so I just want you guys to remember these two values, especially for electrons and protons. So the mass of proton is 1.673 times 10 raised to negative 27 kilogram, and the value of G is 6.674 times 10 raised to negative 11 Newton meter squared per kilogram squared. So these are the things that I want you guys to remember, because if they're not given on your problem, it's one thing that I want you guys to immediately remember. What is the mass of proton? What is the charge of proton? What is the mass of electron? What is the mass or charge of electron? What is the value of G? What is the value of K? So these are the numbers that I want you guys to remember. Now let's solve for Fg just by just plugging in the numbers. We know that the value of G is 6.674 times 10 raised to negative 11 Newton meter squared per kilogram squared, multiplied by the mass of protons. The mass is always going to be positive. That's 1.673 times 10 raised to negative 27 kilogram, multiplied by, let me just move this, multiplied by another 1.673 times 10 raised to negative 27 kilogram. All of this divided by the distance between the two protons squared, which is 3.8 times 10 raised to negative 10 meters squared. And the value of Fg is actually equal to 1.29 times 10 raised to negative 45 newtons. And is this attractive or repulsive? Remember, the gravitational force will always be attractive force. As you can see here, this is very, very small because the repulsive force is stronger. So they attract based on the universal gravitational law. So they attract because of their mass, the gravity that pulling each other, but it's very, very weak. So the gravitational force is this value right here. So you can actually also use Fg to measure a smaller object, but expect to have very small number because it is very proportional. The value of the force of gravity is proportional to the mass. The higher the mass, the higher the gravity. But since these are very small objects, they are very small in their mass, therefore our Fg is very small. Okay, so that's how we use Fg and Fe, universal gravitational law, and the Coulomb's law in order for us to solve these sample problems. Well, what I want you guys to remember for Fg, we do not use the charge. We have to use the mass of the object. Coulomb's law is where we use the charges. So that's sample problem 3.2. And let's add on to our last sample problem. Sample problem 3.3. Okay, now let's read it. Two unlike charges attract each other with a force of 400 newtons. So that's a massive charge or massive force that attracts those two charges. What will be the force of attraction if the distance between them is increased to twice its original value? Okay, so let's write our given first. We are given that the force of attraction between two unlike charges is 400 newtons. And we're also given that what we want to do is we want to increase the distance between them twice to its original value. So we can do with that is we can denote d as the original value, d1 as the original value. But for our d2, let's write f1 here. So this is the force of the original force of the original distance. But for d2, our d2 is twice the value of d1. Okay, so because it says here, what will be the force of attraction if the distance between them is increased to twice to its original value? Meaning if our d1 is the original value, multiplying d1 twice, meaning that's 2 times, that will be the value of our d2. And what is being asked is F2. What would be our new force? Okay, so how are we going to solve these type of problem? Okay, so what formula are we going to use? Okay, so we have to kind of like derive a formula for this problem. Okay, so we know that the formula for our FE, or for our Coulomb's law, is F is equals to K multiplied by Q1 and Q2, the absolute value, divided by the squared. We know from Coulomb's law that the F is inversely proportional to the squared of the distance. Okay, we know this. This is from Coulomb's law. We discussed this the last time. The force is inversely proportional to the square of the distance. Meaning, as I increase this, they should decrease. So in this situation, we increase it. So in this problem, we know that the force F1 should be less than F2 according to Coulomb's law, because it's inversely proportional. If I increase this would be lower. Meaning, if I increase D1, our F1 should be less than F2. Okay, but by how much? So one of the things in algebra, to so one thing that I want you guys to remember in algebra, two quantities are inversely proportional if, okay, I want you guys to remember, if each of their product is constant. What do we mean by this? Since we are looking for F1 and F2, so we know that F1 is equals to 1 over d1 squared, right? And F2 is equals to 1 over d2 squared. But we know that d2, but before we get there, okay, so these two are inversely proportional if, so these two quantities right here are inversely proportional if each of their product is constant. What do we mean by that is if F1 multiplied by D1 squared is equals to 1 and F2 multiplied by D2 squared is equals to 1, meaning these two should basically be equal or constant. So what we're going to do in order for us to find F2 is basically equate these two. F1 d1 squared is equals to F2 d2 squared. And we know that the value of d2 is 2 d1. So F1 d1 squared is equals to F2. We're just changing the value of d2 here because we know that d2 is equals to 2 d1 squared. Okay, now we can actually solve for our we can actually solve for F2 now. So if F1 d1 squared is equals to F2, we're solving for F2, remember, is equals to 2d1 squared. So F2 is basically equal to F1 d1 squared divided by 2d1 squared. And this would be equal to F1 d1 squared. So that's 2 raised by 2, that's 4. That's d1 raised to 2, that's d1 squared. We can cancel the d1, and it will give us F1 is equals to 4. And okay, so maybe in order for us not to get confused, let's move it here. Okay, so F1 d1 squared divided by f2 squared, that's 4 t1 squared. We can cancel t1 squared is equals to f1 over 4, and that is equal to, you know, the value of f1 to be 400 newtons divided by 4. Therefore, f2 is equal to 100 newtons. And does it make sense? It does make sense because we know, or sorry, yeah, sorry, this should be f2. Yeah, is less than f1 because we increase the distance on f2, not d1. Sorry, my mistake. This should be the case, not the other way around. So this makes sense because this should be lower than our f1. It should be lower because the distance for f2 is increased. Increasing the distance, since it's inversely proportional, our f should decrease. Increase in d2 means decrease in f2. So the value of f2 is 100 newtons. So it's a little bit tricky, something that I want you guys to remember. Two quantities that are inversely proportional if their product is constant. So if you're changing something based on proportionality, just remember this. So if two things are inversely proportional, by increasing or decreasing the other stuff, I can measure the change by using this rule right here. Two quantities are inversely proportional if each of their product is constant. Okay, the opposite is true for directly proportional. For directly proportional, okay, so for example, we have f1 is equals to q1 and q2. And our f2 is equals to, let's say, twice the value of both. So we have our q1, q2, 2. Okay, so for this situation, what happens is instead of this situation right here, what happens is f1 divided by q1, q2, 2 is equals to f2 divided by q1, q2, 1. So that's how you would be able to measure these two. So instead of multiplying, we have what we call to call this you inverse it or you divide those two. Okay, so just one thing that I want you guys to remember are these two right here. This is how you solve for equality and based on proportionality. Okay, so if you guys have any question about this, do not hesitate to message me, and may you guys have a great day.